In this video, I'll be going over the process of creating a machine learning project. And again, this is for my MYP personal project, which is centered around artificial intelligence. To begin with our process, we must define a problem/solution statement. So let's say we're dealing with autonomous cars, and this car does not know when to stop or go at a traffic light. To fix this, we can build a model that will classify what the traffic light is telling us. So green means to go and red means to stop, things like that. Now, for my case in my M1P personal project, I have chosen to make several applications surrounding machine learning, and one of them does indeed have a specific problem/solution statement. However, others are simply meant for learning purposes, such as the Safari dataset. I've just chosen to classify images with that. Now, what that does, it doesn't exactly solve a problem in the industry, but it gives me the tools necessary to solve them in the future. It's essentially meant for learning purposes. Well, that was just for my case. However, again, in the industry, we always want to have problems as slash solution statements that we want to go into, as we don't want to just make machine learning models for the sake of it, as they're not the easiest thing to do, and we want to get the maximum use out of them. The next step is centered around data. We need to ask ourselves, where will we collect it? For my case, I could go to Kaggle.com or use the TensorFlow datasets built into the library. However, in the industry, and as seen in the second question, is the data available to you? This is mostly no, as the problem people are trying to solve is very unique and sort of abstract, so a dataset needs to be created or collected themselves. We also need to make sure that the data meets our needs for machine learning. So, for example, we want to make sure that this dataset has good volume, so it can't be too small or the dataset will be difficult to model. We want to have a large amount of training samples. We also want to make sure that this dataset is high quality, as we don't want missing values or null values in it, as this will also negatively affect the model. We also want to make sure that most of our dataset, as not all of it will be perfectly clean, we want to make sure that it has proper training labels or ground truths. So let's say that we're given traffic lights. 50,000 traffic lights for training data, and let's say 10,000 for testing. We have images of traffic lights. We want to make sure each image has a label on it. So if it's green, we will label it as green, red, and red, something like that. Now we want to make sure that all images have ground truths, as otherwise supervised learning simply won't work for our model. This is a very important factor for our data, and now we can move on to the next step. Now moving on to the algorithms/model stage. This is considered to be the most important part of the problem, as it's essentially the center of machine learning. We want to ask ourselves what type of model is required for our solution. Now, back to the traffic light scenario, let's say that we are again classifying traffic lights for an autonomous car. This is essentially image classification, and a great model to use for this would be a CNN, as these are essentially meant for classifying images. So we probably wouldn't want to use something like a random forest regressor, as that will just make our life harder and it won't give us good results. We want to also ask ourselves which model will solve our problem most effectively, such as, again, back to the scenario, we don't want to use a random forest regressor for image classification. We want to choose a model that will make our life the easiest and get us to our solution the fastest way possible. We want to make sure that our model is accurate, can be scaled, and is complex enough for our solution. It also needs to meet our goal, again, which is our solution statement. Otherwise, the model will have no use to us and it will simply take away our time, which could have been used for something else. After we've built our machine learning model, we want to test it and improve its results. Now, this includes optimizing things known as hyperparameters, which are essentially properties of the model which we can fine-tune to increase our accuracy. We also want to check for something known as bias or variance. Now, bias occurs when our model performs poorly on our training and testing dataset. This means our model was not complex enough. Now, variance is quite the opposite. So, variance occurs when our model is far too complex. This means it performs very well on our training data, but performs poorly on our testing data. Now, these are things we want to avoid, and they're great to check for right after we test our data the first time, or our model on the new testing data, which it hasn't seen before, as we want to make sure that it's available for use before we actually put it into production. We want to do everything in the development stage and make sure that it's fine-tuned and we can get it to the highest accuracy as possible, so it will perform the best it can when it's deployed or presented, which is actually the next stage of our process. After we have fine-tuned our model, we want to present our results. Now, this can be done two ways. I've chosen to go to the app deployment route. Now, This is essentially where we take our model and put it on an app so a user can input data and get an output. So for me, it was inputting an image and getting a class. We can also simply show insight. Now, this is more used for datasets that are not really oriented towards image classification, something more on the lines of maybe election data or data for COVID-19. Now, with this, we can create models and predict something for the future, which essentially can be deployed in an app, but rather can be presented to a group of people to give knowledge on a certain topic. This brings us to the conclusion of my video. All the information I went over was gained due to my repetitions and many creations of machine learning applications. Now, I will continue to do this as I believe experience is the best way to gain knowledge on any sort of field, especially machine learning. And that's the end of my video. Thank you for listening.